Today's topic is, sulphonation of aniline. Though this is going to be a repeat one because I've only done in Hindi, this is going to be in, English. So depends your choice. So what I'm going to do right now, I'm going to, convert aniline to, amino-benzene sulfonic acid. This is going to be a little bit, heavier name to you, but this is going to be really easy when you will be practicing the equation. So let me, take you through the equation. Like I said, what I'm doing here is I'm converting this aniline. This is your benzene here, and this benzene has a amino group, and that's why it's called the aniline. So this is your aniline. This aniline react with concentrated H2SO4. This one react with concentrated H2SO4. Probably you do know that this concentrated acid has two ions. One is proton, another is hydrogen sulfate. Right? Now you do know that this one is electron deficient, so this will approach to the lone pair of the nitrogen. So what's going to happen? You are going to have a compound. This is your benzene here, but right now you are going to have NH3 here with the positive charge. Why? Because nitrogen has donated its electron to the hydrogen. So this is called anilinium ion. So this is called anilinium ion. Now another thing is that because this HSO4 is negatively charged particle, so this is also attracted towards the positively charged particle right here. So this goes in vicinity of this anilinium and it stay there as HSO4 negative. So this is your negative part, and there you have your anilinium part. Now this is called anilinium hydrogen sulfate. This is called anilinium hydrogen sulfate. Now, what happened in the next step towards making it, amino-benzene sulfonic acid? You have to heat this, intermediate. So when you heat this intermediate, at around 452 to maybe 472, Kelvin. I tell you something, this is not something you should remember, right? Because even I don't remember. So what I do actually, I just look at before I prepare this lecture. That's why I remember. Otherwise this is not very important to you. So forget about, don't take tension about learning those temperature. So when you heat this intermediate at this particular temperature, water comes out. So water is eliminated, and after water is eliminated, this is converted into this converts into this is your benzene here. Now this is again NH2. This remain as amine group. However, a sulfonic group is added here, SO3H. So this is called benzene sulfonic acid. This is called benzene sulfonic acid. This is also called sulfonilic acid. This is your IUPAC name, however this one is the common name. Finally, we have our result. So what we have done here, we have converted the aniline into the 4-amino benzene sulfonic acid. So I misread something here, so I'm writing it here. So 4-amino benzene sulfonic acid. So this is your fourth position and this is your 1. In case you do know that this has more priority than the amino, that's why the numbering has started from here. So this is your 4-amino benzene sulfonic acid, right? Which I misread earlier. Now in the last step, there is something very important coming up here. Let me introduce to you about. Have you ever heard about Jitter ion? In case you do not, this is really a hell of a topic, very important for the board exam or for any competitive exam you might be thinking. So what this Jitter ion is, I tell you what happened. This proton from sulfonic group, is again transported right there, and it result formation of this particular compound, where you have again NH3 with the positive charge, and down here you have your sulfide with a negative charge. Now just take a look. This is, a compound I am talking, which is called the Jitter ion. So let me remove this a bit here. Benzene sulfonic, sorry for this, sulfonic acid. So this was your benzene sulfonic acid. Now this is your Jitter ion. This is your Jitter ion. Now this is also called, a dipolar ion. A dipolar ion. And this is neutral. This is neutral. Now why this is called dipolar ion? Because within a same molecule, what you saw, a kind of tautomerism here. You probably know that what tautomerism is. So due to the tautomerism, proton from here transported up to the nitrogen right here, and it resulted this dipolar ion, which is a neutral one. However, this is specifically called Jitter ion. So this is something, I wanted to make this happen in this very lecture. I would say thanks for watching.